So I was recording this and then my iPad decided to stop working, so I'm going to re-record it really briefly. What I'm doing here is I'm going to run through G and H, and I'm going to do both directions of G and H. I'm also going to show you pretty much the most straightforward way of doing each one. This direction for G is the hardest direction, but you should practice it. So for this one, I'm going to start off by doing a reductio. Why? Because there's pretty much nothing else that we can do. We could try to do some different and statements here. We could use 35G, but I'm assuming that that's off limits, just for the sake of argument. And I'm going to show you where we end up getting. As much as I hate doing wedge eliminations, we're going to do a wedge elimination, and here's why. Start with negative p, assume for the sake of wedge elimination. Using one of our material implication rules, we can get p arrow q from this. And then we assume q. Using a material implication rule, we can get, you guessed it, p arrow q. And then since both sides have led to, let me just double check to make sure I know where I'm at here. It's 2, 3, 4, 6, 7. Okay. And since both sides of the wedge led to p arrow q, we can affirm, therefore, p arrow q. Three, 4, 5, 6, 7, wedge elimination. Note that this contradicts with line 1, so now we're going to put them together. Why? Because we're doing a reductio, we want a contradiction. And then since we've shown that line 2 leads to a contradiction, we get to say that what we assumed earlier cannot be true. Then we drop the negations. Pay very careful attention to our assumption numbers here. Assumption number matches the line number for every assumption that we were given or that we introduced. Then line 3 came from 2, 4, 6. Then we discharge the 4 and the 6 because this is a wedge elimination. We get 1 and 2 together here. 1 and 2, but since it's a reductio line, discharge the 2, and we end with a 1. This is the most straightforward way of doing this direction. The other direction is easier. So we start off with p and not q, and then we assume p arrow q for the sake of reductio, pull off the p from line 1, and elimination, pull off the negation q from line 1, and elimination, get q from lines 2, 3, and pp. And then you're going to put the q and the negation q together in order to get your contradiction explicit. Then from 2 to 6, we see a contradiction. So then we get to conclude it's not the case that p arrow q. For our assumption numbers, we have a 1 and a 2. 1, 1. And then we discharge the 2. This direction is much easier than the last direction, but do note that this also is a 35G. So if we somehow gave this to you on the exam, you could plausibly just use 35G. Also means we're probably not going to give it to you on the exam. Let's quickly do H. So H looks as follows. Let's just start with the first direction. So we're going to just assume the opposite of the conclusion because the main operator is a wedge, and that's nice.
Okay, oh, the other thing is...
Break these pieces off.
Oh, I said about the dead center. That's kind of stupid.
And then you're going to do a modus tollens between line 1 and line 5.
What is isostacy?
That's the relationship. Right?
This gets us P
Yes and no. It's
and not Q.
I know. It's the idea is kind of like if you put. It's the idea that like stuff is gonna.
Then we pull off the P there.
Something that's gonna be like it's sticking out, like the wood and the water is sticking out something below it. So the idea is that like, yeah, it's floating pretty much.
Then you put the P and not P together because we have one there and we have one there.
Phenomenon too, but that's what it is. Okay, melting temperatures, geothermal radiant. I actually don't know.
Oh, okay, so the melting temperature, I know the melting temperature is like, the melting temperature.
Now, since we've shown that line 2 leads to a contradiction on line 9, what we're going to be able to do is discharge the reductio.
Geothermal actual temperature is simply dependent upon pressure.
And then we chop off both of the double negations. And now you're going to give an assumption number that matches the line number for every assumption that you've been given or that you introduce. And then you just fill in the rest of them. Discharge the 2, and you're just left with 1. And that's how this one should be done. But let's say we were going the other direction. Let's say that we started off with a P or Q. There's a few things that we could do here, and there's also a few things that I wouldn't recommend that you do. So you could try to do a conditional proof here. After all, we do have some rules that allow you to move things into other things. But to be honest, it would get a little bit ugly. So my recommendation, and it's a very strong recommendation, would actually be to do a reductio. Here's why. So we start with the reductio. Then we get P, arrow, Q, and not Q. Get both of those pieces. And I notice that what this is going to give us is this is going to give us all of this stuff. And let's see, where was I going with this? So what this gives us then is this is going to give us not P, and not P is coming from lines 4 and lines 5 variomotus tollens. And now there's a few things that we could do here. We could try to do a wedge elimination, or we could do a disjunctive syllogism. I recommend a disjunctive syllogism. So let's say that we want to get Q. We can get Q from line 1 and line 6 using a disjunctive syllogism. Again, if I say I had a soup or salad and then I tell you, yeah, but I didn't have the salad, you know I had to have had the soup. And now we actually have our contradiction. We have Q and not Q from lines 5 and line 7. Since we've shown that line 2, right there, led to a contradiction down here, we're going to be able to say it's not the case that the assumption we made is true. Alright, then we get rid of the 2 negations there. And we fill in our assumption numbers. That gets a 1, should have an A over here. That gets a 2, 2, 2, 2, 2. Finally a 1 and a 2. 1 and 2. 1 and 2, but discharge the 2, and a 1. If you would try to do this with a conditional proof, you would have had to use a lot more of the equivalency rules, and that would have gone a little bit messy, to be honest. It also is likely, let me just name this explicitly, it is very likely that people would have assumed P arrow Q and then tried to change P arrow Q into not P or Q. Actually, some people did this on their homework and said that this was a contradiction with P or Q, but these aren't the same things. So if you had done that, you would have been making a mistake and you would have gotten the answer wrong. So my recommendation would have been to do it this way.